the new section of circular motion. Friction you will be doing with Hemant sir. We will start with circular motion on this side. It's all mechanics actually, so it's a continuation of the principles of mechanics. So we'll start by understanding the kinematics of circular motion. That is how we describe the equations of motion for a particle that is describing a circle. And then from there on, we'll be discussing the dynamics or the type of forces like centripetal force, tangential force, etc. that occur in the case of circular motion. So free body diagram, Newton's second law and all that is very much going to be part of the analysis in circular motion also. Yes, good evening. Okay, so let's start with the definition of circular motion. So as the name suggests, if the path of a particle is circular, that means its distance from a particular point remains fixed during a two-dimensional motion, then it is called the circular motion. Okay, so we'll just start. Just give me a second. Yes. So the definition of circular motion, okay, if it is a two-dimensional motion which is circular in trajectory. Okay, so circular motion is defined as the motion of a body or a particle such that its path or trajectory is circular. So further, what we mean by circular path or circular trajectory is that it's a motion in a 2D plane, two-dimensional plane, such that the distance from a particular fixed point remains constant. That's how we draw a circle. So that's how we describe a circular trajectory. Motion in a two-dimensional plane such that the distance from a particular fixed point remains constant. It is called the center of the circular motion. The fixed point from which the distance remains constant, that is the center of the circular path. Thanks. Okay. So geometrically, how we represent it is that the 2D plane in which the motion is happening, we will take that as our XY plane. Okay. Or at least we'll take that as one of our rectangular planes. We can take it as XY or YZ or ZX also. But in the standard situation, we take the plane of motion as our XY plane, and the center of the circular path that is taken as the origin. So now our circular path would look like a circle with the origin as the fixed center. So this describes the circular path. With radius capital R and the center point as the origin. Okay, so let's take a common everyday example to try and understand a little bit more about circular motion. So suppose we have a situation like this, that a person jogs on a circular track, okay, at a constant speed of, let's say, 6 kilometers per hour. If the radius of the track is then find time period to complete one circumference, and distance traveled in 50 minutes. I'll give you more things also. First, note down this much and work out this question. So this person is jogging on a circular track at a constant speed of 6 kilometers per hour. Okay. Okay, so just start with this. I'll just yeah. So we want to find the distance traveled in 50 minutes, and we also want to find the displacement, that is magnitude of the displacement, in 25 minutes. Okay, you're copying the above part. Okay. Okay, this is also 50 minutes. Okay, okay. Now start with this question. Okay, so let's understand how this question works out. Okay, so roughly, let's say this is your circular track. Now the radius of this track in which the person is moving, that radius is given to us as 3.14 kilometers. So approximately pi kilometers. So the circumference, that will be 2 pi r. So that is approximately 2 pi square kilometers, or we'll take that approximately as 10 kilometers, sorry, as 20 kilometers, because the question is giving us to take the approximation pi square as 10. So that is the circumference. Let's write that as S. S is one circumference. Okay. And the person is running at a constant speed always. The constant speed of the jogger is 6 kilometers per hour. Okay. So from that you can see the first part. The time period for one circumference is going to be nothing but this. Or so it's going to be 200 minutes or 10 by 3 hours or something like 3 hours and 20 minutes, like that. That is going to be the time period. Okay. So now from this you work out the other two things I told you, that what is the distance in 50 minutes, okay, and what is the magnitude of the displacement in 50 minutes. Okay, work this out. We'll see a couple of other calculations also. So hope this is clear so far. So the particular time interval I've given you 50 minutes is 1/4 of the time period for this complete circle to get the complete circumference to be covered. So if it's 1/4 of the time period, that means you can understand on the track how much distance it's covering, 1/4 of the circumference. And the displacement will be a chord that subtends 1/4 of 360 degrees or a chord that subtends 90 degrees. Deep, you are giving the approximate answer or? Yeah, approximate answer. No? That's correct. Good. 1/4 of the circumference, obviously. Huh? Okay. And what about the displacement? Yeah, that's correct. And what about the displacement? So what we can see here is that suppose the jogger started from here, suppose at some time 0. Okay. Then they would reach somewhere here at 50 minutes. Okay, so that they reach here at 100 minutes. Then again here at 150 minutes and back here at 200 minutes. Okay. So from here to here, the distance traveled, you can see the second part's answer, the distance that will be 1/4 of the circumference or approximately 50 meters. That's correct. Okay. But what about the magnitude of the displacement in 50 minutes? So just coming to that, so you can see that the displacement will be this vector here. So iska magnitude will become how much now? This is what we have to calculate. This is subtending 90 degrees. So it will be r root 2 or 3.14 into root 2. So approximately, say like this. So you can leave the answer this way, r root 2 is also fine. But if we do a approximate calculation, then 3.14 multiplied with 1.41 comes out to be approximately 4.43. So a little less than 4.5 kilometers. So you can see something very interesting here, that okay, so something like 443. Wait. This is kilometers. It should be 5 kilometers. Yeah, it's 4.43 kilometers. So you can see that the magnitude of the displacement is less than distance, because it is not a 1D motion, not 1D motion. So obviously distance covered is going to be more than the magnitude of displacement. That's one thing you can clearly see. Okay, people, hope this is clear. Okay. Now we'll see another example through which we'll understand few things. So next, again, we'll take the case of what we call uniform circular motion. That is circular motion with uniform speed, but this time slightly different values. So a particle P is in uniform circular motion. Okay, you want to write that down? Okay. Fine, fine. Finish that. We'll come back to this question. So hope this is clear. The displacement and distance concept. They are general concepts from kinematics. That distance is the length of the path traveled, whereas displacement is the magnitude of the line joining the initial with the final position. Okay, people, let's come to our second question. Yeah, Harsh, you got it now, understood? Okay. Chord है जो 90 degree subtend कर रहा है, so okay. Now let's come to the second question. So very similar situation, only some new things we will calculate here. So this time this particle is in uniform circular motion. Uniform circular motion का मतलब क्या होता है? It is in circular motion at constant speed. At constant or uniform speed. Okay. With V naught equal to, let us say, 10 meters per second, and 2 pi r, that is the circumference, radius r, such that the circumference is in fact equal to 120 meters. Okay, so we have to find the average velocity from 0 to 6 seconds. Okay. We have to find the distance traveled from 0 to 2 seconds. Okay, and we have to find the average acceleration from 0 to 3 seconds. So when we say average velocity, we mean magnitude of average velocity. When we say average acceleration, we mean magnitude of average acceleration. So these all quantities we have to calculate. So just try to figure out this question we will discuss. So यहाँ पे क्या निकालना है अपने को? Average velocity का magnitude निकालना है. यहाँ पे average acceleration का magnitude निकालना है. Okay. So remember, what is average velocity defined as? It is defined as the total displacement divided by the total time. Instantaneous velocity is defined as rate of displacement with respect to time, but this is average. Okay, just like that, instantaneous acceleration is instantaneous rate of change of velocity with respect to time, but average acceleration is the change in velocity divided by the change in time. So you have to use these two definitions here, this one and this one, for the first and third part. Circumference is given to us and the uniform speed is given to us for covering the circular motion. So from that information, we have to calculate all these things. Okay, so let's see how we will get the first part. So you have to figure out that 0 to 6 seconds mein velocity is changing by how much, no? So again, let's say if the particle started from here at t equal to 0, then where will it be at t equal to 6 seconds? So for that, you can see this information. You can see that circumference is equal to 120 meters and the speed at which it's covering the distance is 110 meters per second. That means the time period to complete one full round is how much? 12 seconds. Okay. Therefore, 6 seconds is half a time period. So it will complete half circumference. Okay. So after 6 seconds, the particle will be here. 6 seconds mein yahan pe hoga. Now, when the particle is here, now one thing you'll just understand from geometry, path agar circular hai, to instantaneous velocity's direction is what? It is tangent to the circle. For any curvilinear path, the direction of the velocity vector is always tangential to the path. So it's like this. Okay. So now you can understand over here what is happening is in 6 seconds, from 0 to 6 seconds, the change in velocity will have a magnitude of 2 v0, that is 20 meters per second. This is a very important point here. Let me explain with a vector diagram also. Okay. So see, in that diagram, what is happening? Your initial velocity is like this now. This is your initial velocity, v initial, which is of magnitude 10 meters per second. This is at t equal to 0. And after 6 seconds, what is happening? Your velocity is changing to this one. Circle ke opposite side pe ho. So it's going to have an opposite direction of velocity. So in 6 seconds, what you've done is you've exactly covered 180 degrees now. Half a circumference. So your final velocity, that is at t equal to 6 seconds, is going to be like this. It's going to be 10 meters per second, but in the opposite direction. So now what is your change in velocity? Delta v from 0 to 6 seconds is final velocity minus initial velocity. So that will have a magnitude. So uska magnitude kitna ho jayega? They are at 180 degrees to each other. No? So the magnitude of that will become v0 plus v0. 20 meters per second. So the change in velocity is equal to this much. Okay. So wait, I'm calculating the average acceleration actually. So let's do one thing. Now let's calculate both the things. From 0 to 6 seconds, we have to calculate both the things. Average velocity and average acceleration. I'll come back to average velocity, but average acceleration. So this. So average acceleration ke liye what we need? Change in velocity upon change in time. Okay. So now you look at t equal to 0, your velocity was pointing in this direction, positive y direction, and its magnitude is 10 meters per second. Now 6 seconds later, you have rotated completely by half a circle. So your direction of velocity has become opposite. Right? It's become along the negative y-axis and its magnitude is 10 meters per second. So what is that change in velocity? Final minus initial. So when two vectors are opposite each other, in general, what is the relationship for a minus b? It is that root of a square plus b square minus 2ab cos theta. So if theta is equal to 180 degrees, then magnitude of a minus b becomes how much? It becomes a plus b. So that concept we are using here. This final velocity and the initial velocity, they are at an angle of how much? 180 degrees. So the difference of the two, final minus initial, will become twice of V naught. Is it clear now? Have you understood, Harsh? 6 seconds के बाद मेरा velocity क्या हुआ? Its direction is reversed, but its magnitude is same, ना? So the change in velocity will be just become twice of v naught or 20 meters per second, and the time change is how much? 6 seconds. So average acceleration कितना आ जाएगा? Delta t is 6 seconds. Okay. So the first thing I'll get is the magnitude of average acceleration will become magnitude of delta v by delta t. So that is 20 meters per second divided by 6 seconds. So that is 10 by 3 or 3.33 meters per second. This is my magnitude of average acceleration from 0 to 6 seconds. This is the part I actually added. Later I added that you also want to calculate average acceleration. Okay. Now we also want to calculate the average velocity in this. So average velocity क्या होता है? It is displacement upon time. So magnitude of average velocity is magnitude of displacement divided by time. So for 0 to 6 seconds, what is going to be my 0 to 6 seconds? What is the magnitude of displacement? It's one diameter. No? Okay. So it will be 2r divided by 6 seconds. So 2r I can write as 2 pi r divided by pi. No? So 120 by pi divided by 6. So this will become 20 by pi meters per second. This will be the magnitude of average velocity from 0 to 6 seconds. Whereas this is the magnitude of average acceleration. So this was my first part. I wanted to calculate magnitude of average velocity and magnitude of average acceleration from 0 to 6 seconds. These two things. So hope this is clear. Now use this same method to calculate the second and third part. Second is very easy. Third is again just like the first one, like we calculated average acceleration from 0 to 6. Now I want you to calculate from 0 to 3. Okay, I'll explain beta Harsh. So see what is happening ना, मेरा circumference कितना है बताओ? 120 meters है ना? See what is the information that is given to me. Two very critical information is given. Radius is not given, but circumference is given. Okay, and the speed is given. Got it, Nabita Harsh? So now from that, see what I know from this information. I know that the time period to complete one circle will be how much? 12 seconds. This is for one full circle, okay, or 360 degrees. To cover that full 360-degree angle, so that's why for 6 seconds it's becoming half the time. So that is from the information given in the question. Huh? You might have missed that. Okay. Okay. Now do the second and third part. Okay. Again, you have to use the same information only. For the second and third part also, you have to use this fact that the full circle takes 6 seconds, sorry, takes 12 seconds to cover. So you have to use that information here. Right. So third part you have to find the distance traveled, na beta. So distance traveled to meters में आएगा ना in 2 seconds. So 2 seconds is going to be 1/6, na. See, again, once again, the third part we'll use that concept only, that time period to complete this uniform circular motion is 12 seconds. Therefore, in 2 seconds, the distance traveled will be how much? 1/6 of this, no? Because this time of 2 seconds is 1/6 of the time period. Or speed is 10 meters per second. So distance is speed into time, no? So either way you can see. So distance traveled is 20 meters. But on the other hand, if we were interested in the displacement, let's just quickly look at that also. The displacement in 2 seconds, how much that will be? Suppose it starts from here at t equal to 0. So it would reach here at 1/4 of the time period. It would reach here at quarter of the time period. But where it would reach at 1/6 of the time period, it would reach over here. Okay. So this angle it would cover would be 60 degrees, because in capital T it turns through 360 degrees. Therefore, in T by 6, it will turn through 360 by 6 or 60 degrees. So supposing I had also asked you to calculate the displacement. The displacement would come from this now. You would calculate the displacement as this. Okay. So this would become something very easy, because see, this would become an equilateral triangle. Therefore, in the magnitude of the displacement would be equal to r. Okay, I will take you back to that also. Okay. So I have not asked you exactly in this question to find out the magnitude of displacement, but I'm just adding this. Okay. So also in 1/6 of the time period, or 2 seconds, the magnitude of the displacement is equal to 60 by pi meters, or 120 by 2 pi meters. Okay. So the distance traveled is this much. Okay, this, and the magnitude of the displacement is this. And again approximate it when 60 divided by 3.14, about 19.1. So you can see that displacement has a lesser magnitude than the distance traveled, because of the same reason. It's a circular path, not a straight line path. Okay, so this is clear. Now let's come to the last part. Now in the last part, not 2 seconds, but in 3 seconds, now you have to calculate the average acceleration. So back to calculating average acceleration, but in 3 seconds. So now that you have seen so much, it should be pretty easy. Just use all the information you have in this screen only. Just like we had calculated average acceleration here now, we calculated average acceleration for 6 seconds. Use the same method exactly to calculate average acceleration for 3 seconds. Should be pretty easy. Okay, work it out quickly. Yeah, so anybody got the average acceleration? First tell me what will be delta V in 3 seconds now. How much will be delta V? Yes, very good, beta. Deep, that is correct. Then just divide it by the time and you got average acceleration. Yeah, I got it, 10 root 2 only. Okay, because 3 seconds, how much of the circle it is covering? 1/4 of the circle, no? So your velocity vector is turning by how much? By 90 degrees. Okay. That's what we have to understand here. That in that 3-second interval, you're covering 1/4 of the circle because your time period of the circular motion was 12 seconds. That's a uniform circular motion. So let's say you assumed you started from here at t equal to 0, going at that uniform speed. So in 3 seconds, you'll be here because that 3 seconds is 1/4 of the time period. The time period was 12 seconds. So your velocity vector, it is changing from vector of magnitude 10 here to a vector of magnitude 10 in this direction. So it is rotating by how much? By 90 degrees. Yes, very good, Harsh. That's correct. 10 root 2 will be the delta V. You know, and just divide that by the time. So you got the average acceleration now. Right. So this is our vector diagram. This is our initial velocity at t equal to 0. And this is what the velocity is becoming after 3 seconds. This is our initial velocity at t equal to 0. This is what our final velocity is becoming when we are considering the time to be 3 seconds. So both are of same magnitude, 10 each. So our change in velocity, final minus initial, will become this vector here. Delta V will become this. The vector joining the head to head. So this is our delta V, which is V final minus V initial. Now this is easy to calculate because this is a 90-degree angle and plus it's an isosceles triangle. So delta V has a magnitude of 10 root 2 meters per second for a time interval of 3 seconds. So therefore, average acceleration will be the magnitude of this change in velocity upon the time. So 10 root 2 divided by 3 meters per second. Yes, something like that. That's correct. Okay. 10 root 2 by 3 we can write as approximately 10 into 1.41 by 3. So 14.1 divided by 3. 12, 41. So 4.7 approximately. Yes. Slightly greater than 4.7. So we can approximate it as 4.7 meters per second square. So got it now. Hope this is clear to all of you. Okay, so these are just some basic things to get familiar with circular motion. And remember that the two examples we've done, we have only dealt with one type of circular motion, that was uniform circular motion. So whenever we use the term uniform circular motion, we mean circular motion at constant speed. Whereas many a time that's not what's happening. Okay. The circular motion might be happening with variable speed. So that is called non-uniform circular motion. Okay. At uniform speed, the magnitude of velocity, which is the instantaneous speed, they should be constant. Okay. Whereas we also have something called non-uniform circular motion, which we'll be looking at in detail. So non-uniform circular motion is one where there is variable speed. That means the magnitude of velocity is variable. Whereas here the magnitude of velocity is constant. So if somebody asks you, can we have circular motion at constant velocity? The answer is no, because obviously constant velocity means the direction of velocity should not change, and that cannot be a circular path. In a circular path, the direction of velocity is constantly changing. But can we have circular motion at uniform speed? Yes, the answer is we can, and that's called uniform circular motion. Okay. Now we will come to a very important set of definitions in circular motion. Okay. And that is something called the angular parameters. So these are a set of variables used to define the circular motion. Parameters of variables. They are a set of parameters of variables used to describe the kinematics of circular motion. Okay. Kinematics का मतलब क्या होता है? Basically the equations of motion. Like for 1D kinematics, you have those type of equations that if acceleration is uniform, v is equal to u plus at, etc. So that is for projectile motion. You have a set of equations like x is equal to u cos theta t, y is equal to u sin theta t minus half gt square. So like that for circular motion, we define the kinematics by a set of equations where we use a different set of parameters or variables, and those set of parameters and variables are called the angular parameters. So let's understand their definition. Okay. So remember, we always describe the circular motion to be in the xy plane, with the center of the circular path as the origin of our coordinate system. So that is the standard procedure for us. Okay. So now on this circular motion of radius r with the center, so this is a circular motion in the xy plane, okay, with radius capital R and the center at the origin. Okay. So now if the particle is located at some point like this, so P is the location of a particle at instantaneous time t, let's say. Okay. The particle is in circular motion, of course. Okay. Then the position vector of the particle, as you know, how we define position vector by this. No? This is called the position vector. The coordinates are x, y. The position vector is x I cap plus y j cap. Okay. Okay. Now, if the position vector is making some angle with the x-axis, that is called the angular position. So that is the first parameter for us. Out of the angular parameters I was telling you about, the first definition for us will be angular position, and that will denote with the symbol theta, and it is expressed in radians. So what is the angular position? It is the angle made by the position vector OP, also you can call it, okay, with respect to the x-axis. Whatever we have defined as our x-axis, the angle that the position vector is making with the x-axis, that is called the angular position. Okay, and in this, the sign convention that we use is that anti-clockwise angle is positive and clockwise angle is negative. Okay, so for example, if a particle is located over here, okay, then this angle, it will be like, let's say, plus 60 degrees or plus 45 degrees or whatever. But if a particle is located over here, then its angular position will be written as minus 60 degrees or minus 45 degrees or whatever that position is, but it will come with a negative sign because clockwise is negative, okay, and anti-clockwise is positive. That is the right-handed system that we use. The same system that we used to use for the cross products that we defined earlier in vector algebra. The same system we use over here also. That anti-clockwise stands for positive and clockwise stands for negative. So just make a note of this definition first, angular position. Another important thing about angular position is that it's a dimensionless quantity. As far as units and dimensions are concerned, this is dimensionless because angle is defined as arc upon radius. So it is a dimensionless quantity. Radian is a dimensionless unit. Okay, so you understood the concept of angular position. Now the next thing we will see, very important here, is the concept of angular displacement. Okay. So I'll just use this same diagram to explain. Now what happens is that if the particle moves along that circle, so you're still writing, okay. Okay, Bhargav, finished, beta? Okay. Now see, next thing. Acha, Harsh, you're writing, okay. Yes, with respect to positive x-axis, that's correct. Okay, when we say with respect to x-axis, you can add this point here with respect to positive x-axis. Okay, so the anti-clockwise angle that you're making with the positive x-axis, that is called the angular position. Okay, now next point, let's understand the concept of angular displacement. Okay. So next definition for us here will be angular displacement. So this we can denote with delta theta. So that is the change in angular position. Okay, it is nothing but change in angular position. So we can define the angular displacement as the change in the angular position. Okay. So for example, if the particle was here at time t1, it was at position vector r1 at angle theta 1 at time t equal to t1. And then from here, the particle moved to this different angular position. Let's say it moved somewhere here. As part of its circular path, it moved at t equal to t2 to this new position. Okay. So this whole angle is now theta 2. So the angular displacement between time t1 and t2 is going to be this angle here. This is going to be our delta theta. Okay. This is our delta theta. Okay. So here you can see that from t equal to t1 to t equal to t2 is going to be this. So this is the definition of angular displacement. Change in angular position. Okay. Angular displacement is also measured in radians, SI units, and it is also a dimensionless quantity like angular position. Okay. So it's a very simple definition that displacement is always change in position. So when we talk about linear displacement, it is change in linear position for 1D motion. So like that for angular motion or rotational motion or circular motion, the angular displacement is defined as the change in angular position. No, theta 2 is the angle with respect to the x axis. देखो क्या हो रहा है ना, टाइम t2 पे उसका एंगल x एक्सिस के साथ थीटा 2 है, t1 पे कितना था, थीटा 1 था. So change कितना हो गया, that one is delta theta. Okay, so in the diagram you can see that delta theta is the angle between the r1 vector and the r2 vector. But what is theta 2? Theta 2 is the angular position at time t2. Theta 2 is the angular position at t equal to t2. That is the angle of r2 with respect to x-axis. Okay, theta 1 was angle of r1 with respect to. This was the angular position at t equal to t1, which is the angle of r1 with respect to x-axis. So अभी इन दोनों में जो change आ रहा है delta theta, that is the angular displacement. Okay, so if something, for example, goes from an angular position of 30 degrees to 60 degrees or 30 degrees to, let's say, 45 degrees, then we'll say angular displacement is 15 degrees or pi by 8 radians. Sorry, pi by 12 radians. 15 degrees will be pi by 12. Okay. Now, as you would have guessed that after displacement, the next thing that we describe in kinematics is always velocity. Okay. So our next parameter, it is called angular velocity. Okay. And we denote it with the symbol omega. It looks like a W, but this is actually omega symbol. Okay. So angular velocity is defined as rate of change of angular position with respect to time. So like you would have learned in calculus, any rate of change is defined in two ways: average and instantaneous. So average angular velocity is defined as average rate of change of position with respect to time, or basically it is the angular displacement ratio with the time, that kind of thing. Okay. Whereas the instantaneous angular velocity, that is defined as the instantaneous rate of change of angular position with respect to time. Okay. So this is average rate of change. This is instantaneous rate of change. Okay. And one way or the other, it is expressed in radians per second. Okay, that is the unit. And the dimension becomes capital T inverse, inverse of time. Or you can say it is m to the power 0, L to the power 0, T to the power minus 1. Because radian is dimensionless, so divided by second. So this is the definition of angular velocity. So another thing is about the Sine convention. Okay. Anti-clockwise is positive and clockwise is negative. Yeah, you can find the angular position by trigonometry also, especially if you are finding the relationship between the xy coordinates and the angular position, and we'll be coming to that also soon. Okay, but here see, here's the point is now it's more about that we are describing the position in terms of angle. No, matlab, that's the idea about the angular parameters. Okay, I'll explain in a moment. Okay, so suppose we have an example like this. Suppose that we have a particle in uniform circular motion. Okay, with a time period t is equal to, let us say, 6 seconds. Okay. Now at t equal to 0, its angular position is theta naught equal to pi by 6 radians. Okay. So draw a circle to represent its path. Okay. Show its position and angular position at t equal to 0, and then at t equal to, let us say, 1 second, then again at t equal to 2 seconds. Okay. And then we also want to find out the angular displacement from 0 to 1 second and from 0 to 2 seconds. Okay. So through this, we will understand a little bit more about the angular parameters. Okay, what they mean. Let's understand this question. In fact, let's add one more thing. Find its angular velocity. And another information given to us that it's doing anti-clockwise circular motion. Uniform circular motion in the anti-clockwise sense it's doing. Okay. So let's assume all this information is given to us. Yes, time period is the time taken to complete one full circle. Okay. So time period का मतलब ही होता है, we define that as the time taken to complete one circumference. Okay. Or now we'll understand that it is for angular displacement of 2 pi. Okay. It is the time taken. When the time taken is one time period, the angular displacement is 2 pi radians. Okay. And uniform circular motion का मतलब क्या है? Constant speed. Constant speed. So its initial angular position is pi by 6. Now see what it's saying, that the initial angular position at t equal to 0 is pi by 6. So pi by 6 is 30 degrees. So that means where this is where it was at t equal to 0. I mean, roughly speaking, you don't have to draw an exact angle. You just label the angle. So this initial angular position, theta naught, let's say, that was pi by 6. This is where the particle was at t equal to 0. Okay. And it has a time period of 6 seconds. Okay. So that also tells me that you're showing the position at t equal to 0. So at t equal to 1 second, it will have covered how much? 1/6 of the circle. Okay. So you can see over here that if the time period is equal to 6 seconds, that means in 6 seconds, the angular displacement is 2 pi or 360 degrees. Okay. That means in 1 second, the angular displacement should be 2 pi by 6 or 60 degrees. Okay. In 2 seconds, angular displacement should be 2 pi by okay, or 120 degrees. So accordingly, you can see that the particle will be located over here at t equal to 1 second, because the angular position at 1 second should have become how much? It should have become 90 degrees or pi by 2, because it's starting from pi by 6. Okay. So this angular displacement, that is pi by 3. So from this you can see that the angular position at t equal to 1 second is the initial angular position, but the plus the angular displacement in 1 second. So that is pi by 3 plus, sorry, pi by 6 plus pi by, that is pi by 2. That is 30 degrees plus 60 degrees. That is 90 degrees. Similarly, the angular position at t equal to 2 seconds will become the initial angular position plus the angular displacement. So that is pi by 6 plus now this angular displacement is 2 pi by 3. Okay. So this is becoming 30 plus 120 or 150 degrees. 5 pi by 6. So at t equal to 2 seconds, particle will be somewhere here. It will be more symmetric. So I'll just draw it. This is where the particle will be located at t equal to 2 seconds, because it would have a net angular position of 5 pi by 6. So you see, we found out the position at 0, 1 and 2 seconds, and we found out the angular displacement from 0 to 1 second. That is this. This is the angular displacement from 0 to 1 second, and this is the angular displacement from 0 to 2 seconds. This is our second part. So that's the first part. This is the second part. This is the third part. Okay. Now, what about the angular velocity? Now, here, this is very important. Okay. So, pay attention to this fourth part here. So, what is happening is that it is a uniform circular motion. So, uniform circular motion means that that implies that this speed is uniform. So that also means that the angular velocity, that is also uniform. So this is very important. If the speed is uniform, it means that the angular velocity also becomes uniform. Because if it's covering equal distance in equal interval of time, it is also covering equal angular displacement in equal intervals of time. No? So further, if the angular velocity is uniform, that means d theta by dt is the same thing as delta theta by delta t. Uniform rate of change का मतलब यही होता है that instantaneous rate of change is equal to average rate of change equal to a constant. This is what that means. Okay. So the angular velocity here will become, now the time period is this. No? So delta theta will be 2 pi in one time period. So that is given to us as how much? 6 seconds. No? So 2 pi by 6 or pi by 3 radians per second. Okay. So this has a uniform angular velocity of pi by 3 radians per second. Because it is a uniform circular motion. Okay. So hope this concept is clear to all of you here. So this is a very critical thing to understand, that if the circular motion is happening with uniform speed, that means it covers equal distance in equal time. So the distance we are talking about is arc lengths here, because it's a circular path. So if it is covering equal arc lengths in equal interval of time, that means it's covering equal distance in equal intervals of time. Yeah, these are the angular displacement. Delta theta हमने जहाँ लिखा है ना, वो angular displacement. Delta theta is angular displacement and theta is angular position. So the angular position at 1 second is initial angular position plus displacement. So that's 30 plus 60, 90. The angular position at 2 seconds is initial angular position plus displacement. That is 30 plus 120. So 150 degrees. Okay. So this is the angular position. This is the angular position. But what is the angular displacement? This one from here to here. What is the angular displacement from 1 to 2 seconds is this one. What is the angular displacement from 0 to 2 seconds is this total angle from here to here, which you can see is 2 pi by 3. Is it clear, Bhargav? Okay, so I hope the concept of angular displacement is clear here, beta. Okay. And next thing is angular speed. No? Yes, angular displacement is changing. No? From time to time, it's changing. Just like if a body moves along a straight line, its displacement is changing. No? So like that, if it moves along the circle, its angular displacement changes. No? Yes, it has to be given from which time to which time. It's just kinematics. No? If I ask you in kinematics make displacement, what is the displacement of a projectile? That doesn't make sense unless I tell you, no, from what time to what time. So like that in circular motion also, it doesn't make sense if we don't know the time. Yeah, here why angular velocity is same, because it is uniform. Just like in 1D motion also, if you have uniform 1D motion, the velocity is uniform. The velocity is constant. So ds by dt is the same thing as delta s by delta t. So like that in circular motion, if your circular motion is happening with uniform speed, that means angular velocity will be constant. D theta by dt will be equal to delta theta by delta t. Yeah, Harshita, we'll pick up some of the doubts from Newton's laws of motion remaining in the next week when we have a lecture. Okay, you can send me the doubts on WhatsApp, and some of them I will reply, some of them I'll take up in the class. Okay. Okay, people. So we'll conclude our lecture today. And like I just told Harshita, that if you have any doubts pending in Newton's laws of motion, or you're completing the exercise of Newton's laws of motion and you find you have difficulty in any of the questions, please keep them ready. In one of the lectures next week, I'll keep aside some time for discussion of doubts. Okay, so that's it for today, people. Wish you all the best.